I wanted to do a quick recording to help you with one of the exercises this morning in chapter 3. I'll try to do some additional recordings for the others. But the bug one seems to be giving people some issues, and I think it's more the concept than the actual coding. And one of the reasons that I'm having you do these exercises from the write-ups that I've posted from the textbook is one, because this will be the same type of format you'll see on the free response. They'll give you the outline of here are the names of the methods we want you to use, here are the parameters we want you to send to the methods, here are the methods we want to be void. That's the same type of write-up you're going to see on the FRQs where they're going to ask you to fill in code. And it's not to limit you or to restrict you, but I also think it's very helpful for new programmers if instead of being told write a class that moves a bug, you're actually told here's an idea of the methods that you should have. So if you look at that write-up, you have to sort of assume and infer some things from it, much like you'll have to do on the AP exam. So the outline that they've given you, now we'll just ignore my code in here for a second. But the outline they gave you was that you would have a constructor that would take one integer as a parameter, and it would be called initial position. So that's exactly what I've set up here. I've set up the header for the constructor just as they've told me to, using this parameter value that I'm passing in. Then they told me I would have a move method that would be void, so I set that up. They told me I'd have a turn method that would be void, so I set that up. And then they told me I would have an int get position method that would return an integer, but notice it doesn't take anything in the parentheses, and I set that up as well, just like they asked me to. And then in my tester, I use something similar to what they described. You don't have to start at 10, I just did because that's what they did. We're visualizing this as a bug moving on a horizontal number line on the X axis. If we're thinking about an XY grid, we're not worrying about Y coordinates. Our Y is 0. We're just moving him along the X axis. And they did like move, turn, move. I did a few extra so that I can talk about the output a little more, because on theirs you moved it to 11, you turned and you moved it back to 10, so your printout is going to be 10, and I don't think that's a true test. If I'm putting 10 in and I get 10 back as my output, I might have a logic error and not know it. So I don't like that as their example. They needed to put a few more moves and turns in there. So then I followed their example of printing out the final position. Now they also want you to put out the expected position because they want you to go through the process of, in your mind or on paper away from the compiler, figuring out what the position should be at the end, because that's the only way you can check if your code is right. Just because it runs and compiles doesn't mean it's right, doesn't mean you don't have a logic error. So they want you to go through the mental exercise of saying, if I start at 10 and by default, they tell us the first move is to the right. The bug defaults moving to the right on the x-axis. So my first move to the right puts me at 11. When I turn, I don't move. I just face the other direction. So now I'm facing left. I haven't moved. I'm still at position 11. Now, because I'm facing left, I'm moving 1 to the left. I'm at 10, 9, 8. Now I'm going to turn back to the right. I don't move. I'm still at 8, but I'm facing right. Now I'm moving to the right 1, 9, and when I run, I should get a 9. And they want you to put that, what your expected answer is, so that you can tell if you have a logic error. So that's the whole point of that whole expected line. That's not just to give you extra busy work. It's so that you can verify your code is correct. So we're going to talk a little bit about what we're doing here. They give us parameters. We move 1 unit at a time. We move to the right first by default. Turn faces in the opposite direction that we're currently facing. If I'm facing right, I need to face left. If I'm facing left, I need to face right. So you can use the skeleton outline that they've given you, but don't be afraid to make some assumptions to make some decisions on your own in order to get the code working. Because you're not going to get it working if you strictly follow what they've given you. They haven't told you the mechanism for determining whether you're pointing right or left. That's up to you. There are at least 5 or 6 different ways you can do this program. So what I've decided to do is I've made an assumption, I've made a decision on how I'm going to determine whether the person is facing right and moving right on the positive, or they're facing left and I'm subtracting 1 as they're moving toward the 0 on the y-axis. So in my scheme, right is going to be represented by a positive 1 and left is going to be represented by a negative 1. You could use Booleans here like a true false. You could use 0, 1. You could use all kinds of different schemes to come up with how you're going to determine right or left. I've done positive 1 and negative 1 because think about it, I'm going to be moving 1 to the right, that's plus 1. If I move to the left, I'm subtracting 1. So that for me seemed to be the logical choice. So now let's talk about the instance variables. Obviously, if I want to print out the final numeric position of the bug, position has to be an instance variable. So that's how you've got to start thinking. They're not telling you what the instance variables are. You have to make a decision. I need to track the person's position at the end. I need to print that out. That variable needs to be able to be manipulated in the constructor and the move methods, and I need to be able to print it out. So I must need something to hold the position that's an instance variable. You can name it XYZ, ABC. I chose to name it position because that's a meaningful, logical name. Now, as I was working through this, at first even I thought I only need 1 instance variable to track the position, but as I worked through the code, I realized no, I need a second instance variable because I do need to know the position. I need that to persist throughout every method, from the constructor to the move to the turn. I need that to persist or exist, so it must need to be an instance variable. I'm never going to print it out for the user, but I still need it, and it's got to be at this sort of global higher level. So position and direction are the 2 characteristics of the bug that I care about. And so I'm telling you this because even I, as I work through code sometimes, realize as I'm working I need another instance variable. You will not always know when you start to sit down to code. You may not always realize how many instance variables you need. So it's perfectly acceptable as you're working to go, oh, I need another one, and to add one. Now I put them at the top of the code. You could also put them down here at the bottom right before that last closing brace. It's up to you. So I put them at the top. And I put a comment in so anyone looking at my code can see what I'm doing, and so that I can remember later on, if I come back, I can remember how I designated right and left. So I just put a couple simple comments. Right is plus 1, left is negative 1. So we know we have a default constructor available, so if I never coded my own constructor, I would have the ability to create a bug. The problem would be that I would create this bug, and let's create a separate bug here so you can see how the default constructor works. So I could come in and create a bug with the default constructor. It takes no parameters. You cannot send a value to it. So let's see when I do that. Let's see what my position is. If I use the default constructor, what does it substitute? Oh, I used the wrong name. What does it substitute in there for my position? Notice, get position, which is simply a getter or accessor method. All it does is return the value in the instance variable position back. If I use the default constructor, it defaults position to a 0. Okay? And I'm sure if I printed out location, direction, it has defaulted that to a 0 as well if I were to print that out. Not very useful, but it is available. So because that generic default constructor that all compilers provide to you, whether they show it in the class file or not, because that's not very useful because all it did was default my numerics to zeros, I'm going to create my own constructor. Now, if you came to any of my lectures or watched my recordings on classes and objects, you know that to set up a constructor, whatever the class name is right here, that must match exactly. That is the constructor name. And the only other thing I do is I put the word public in front of it. Not public class, that's up here. Not public void, not public int. Constructors are void in the sense that they never return anything. Really, the sole purpose of this constructor is to allow me to initialize and populate with my values the instance variables of this class, position and direction. That's it. They don't send data back. They don't allow me to, really send anything back to main. I can pass information to it as I need to do to populate my instance variables, but that's it. So you don't put the word void here, but I guess you could say they're void in the sense that they don't return anything. That's what void means in the context of a class file. It doesn't send anything back. What it does is it primes that memory and initializes it, so it allocates memory for two integers, position and direction, and then it populates them with the values that I tell it. That's its purpose. That's it. So I'm going to send in initial position, which would be 10 in the example, and notice I'm going to take the instance variable position, set it equal to the parameter I passed in. And you have to do it this way: position equals initial position. Don't do initial position equals position, because then you've basically, you've totally backwards there on what you're doing. You're not going to get a 10 in your instance variable if you do that. So it's got to be instance variable equals parameter from the parentheses here. Okay? And then I'm going to default my direction to the right. I have to do that. And the way I do that, because the compiler doesn't know that the default is right, and the way I do that is to set direction equal to 1. So I don't have to pass in the direction, but I do have to put a line of code in here initializing it to the value that I want. So now I've got my constructor done. If I now want to move one to the right, here's my move method. Notice move does not send any values back. It's void, meaning it doesn't send any values back. It's a mutator method. It's going to manipulate the value in the instance variable position, okay? But notice also that unlike a constructor which has two pieces of information at the beginning, public bug, right? This is public and the name of the constructor. The methods will always have three pieces of information: public, the return type, and if it returns nothing, you must put the word void, meaning nothing, and then the name of the method. So here I've got public void move. I'm going to take whatever position the person has. It starts off at 10, and then notice that the direction is to the right. I'm adding 1 plus 1. That moves them to 11. Okay? Now if I want to turn, again, they told us this is a void method. It does not send any data back. It's void, but I'm going to put a little if statement in. If I'm facing right, turn me left. Notice I'm not moving. I'm not actually moving on the number line. I am simply changing my facing direction. If I'm facing right, which is signified by 1, so I do if direction equal 1, flip me. Turn me to the left, set my direction to -1. If my direction equals -1, flip me to the right. Okay, and I'm running out of time. I'll have to do another recording. But then here's my get position accessor that simply returns. Notice it returns an int. So I put public int to signify you're getting an int back, tester class. That's my accessor that sends the value back to bug, that lets me print it in a print line. Notice the ones that are void, just you put object name dot method name, object name dot method name. But if they send something back, you either have to put them in a print line or you have to set up a variable to hold the value coming back. And I'll talk about that in another recording.